Mr. Tweed. Mr. Tweed, up here. We bestow on you the engineering coat of authority. Wear it with pride, along with the Zeus Book of Knowledge and Accuracy, especially for those pesky thread sizes. The 6-inch rule, for all that is straight and true. The memory retention device.
It's a big biro.
It's the best we had at the time.
Do you have the lid?
No. Sorry. And lastly, the cloth of cleanliness. No, sorry. Wrong one. So go forth, Mr. Tweed, and engineer. Oh, and could you turn the lights out? Price of power and all that.
Hello, Gladstone. Right, let's get to it. Oh, well, bloody Jenkins. Oh, hello and welcome to Tweed's Garage. In this video, we're going to be talking about work I've been doing on the Riley. Yes, I know. Keep it down. Shush, 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 shush. There we go. Yeah, so in this video, I'm going to be sort of showing you work that I've been doing on the Riley over the past few months through the magic of video and interpretive dance. Yes, so yeah, little bits of work being done. Unfortunately, it was really cold at the time and I didn't have the sound on. I was just trying to get on with it and I've put it all on my computer and it's a right mess. I'm trying to sort it out. So what I'm going to do is take you around and then splice in some video of work I've been doing and explain to you what I've done to it because I can't remember. So buckle up, grab your tea, let's go. So I'm going to make a temporary fuel tank for the Riley, but for other vehicles as well, so I don't have to keep putting fuel in vehicles and having it going off over time. Just have a small amount of fuel that I can use when I want to run a vehicle. So I've got these. I've got a couple of these. These come in these compressor kits of tools. When you buy a compressor, you get a load of tools that come with it, like a blower and a tyre inflator, and then these sort of underseal or paraffin guns. And I've got two of them. Never used them, so I'm going to sacrifice one of them to make a temporary fuel tank. So I've got that. I've got a fuel tap here. Yeah, whether the PTFE will last, I don't know, but it's not going to be used very often, so I should imagine it'd be okay. A bit of brass for the bottom to solder in a fitting in the bottom, drill a hole in the bottom, solder it in, and then a piece of aluminium to turn up a top to screw in with an eyelet at the top, so I can sort of hang it down from the ceiling above the vehicle that I'm running. So let's get cracking. So I've measured this thread and it seemed to be a 3.5mm pitch metric thread pattern and about 29mm for some strange reason. So let's go and take our bar stock over to the lathe and start knocking something up. So I chucked up the piece of aluminium in the lathe and proceeded to turn it down to 29mm for my threaded part of the top, and then used a parting off blade to machine a groove at the back end of it to give me clearance for the threading tool to run into, and also to be able to sort of put an O-ring on it to aid sealing the lid when it goes on the tank. And with the lathe set up for screw cutting, I ran a scratch pass and checked it with my thread gauges to make sure it was correct, and with that done it was a case of engaging the half nuts and to start machining it. Because it's a metric thread on an imperial lathe, I have to have the half nuts engaged all the time, and because it was a coarse thread and a short run, I really couldn't film it because I was having to watch the tool and stand on the brake as soon as it sort of got to the end of its travel. So ran it backwards and forwards a few times, cut the thread down to the measured depth, and yeah, it turned out really well. So the bottle screws on there nicely. So I then moved over to the milling machine and milled some sides to the lid to make it easy to be able to sort of screw it on and off, and then milled a hole through the top of it to allow me to hang the thing up when it's full of fuel, and then just finished it off on the sander just to sort of round the machine sides off to make it nice to handle. So with that done, it was chuck up a piece of brass and drill and turn that down to make a flanged outlet for the fuel tank. Machined it down to 10mm because the tap I had uses 10mm compression olives. So with that machine down, just sort of check that the olives would fit on there okay, which they do, and then just sort of parted that off, ready to solder onto the tank. So I took my Dremel with a little flat wheel on it and cleaned off the paint around where I was going to solder the outlet flange onto. And once I'd got that cleaned up, it was a case of checking the fit of the outlet union and then fluxing it all up and soft soldering it into place. Just gently heating the brass union first to get the heat to transfer down into the steel tank, and then just flow the solder around. And it went really well. So removed the heat from the job and let it cool down a bit, then wiped off the surplus flux whilst it was still warm, let it cool down, and cleaned the solder joint up with steel wool just to get rid of any last remnants of flux, and then fitted on the fuel tap. So just a case of dropping it on and a couple of spanners and squeeze up the olive down onto the union. And off camera I turned up another brass spigot to go on the outlet, and this would allow me to push fit rubber hoses on it to connect to whatever vehicle I would be testing at the time. And then just like the other end, it was 10mm, so just pinch down the olive and that was the job done. So as you see, lid goes on nicely, and you just hang a bungee from the rafters, hook the tank on, turn your tap on, and away you go. So Gladstone is now wearing his radiator. Before I could fit the radiator back on, there was a couple of jobs I needed to do. So the first job to do was to clean up the threads on the mounting studs that come down from the bottom of the radiator. They were a bit rusty and a bit worn in places, but I think there's enough on there to hold them. So I ran a dye down them and cleaned the threads up, and then I turned up 2 stainless steel flange nuts to go underneath. And I don't know where the bloody hell they are. Hang on a minute. So the old nuts were a bit of a mess, so I turned up these 2 flange nuts in stainless to mount the radiator on the cross member here. So hopefully they shouldn't sort of rust away as bad as the old ones. And got a built-in washer there to spread the load. I might put might drill the studs and put a split pin in the bottom of each of them just in case these come loose. So I don't want to lose them down the road. So yeah, so turn them up. They're not on at the moment because the radiator is just sitting here temporary, because I needed to check the alignment for the hoses and things like that. So I also made up this temporary bar, stay bar, to support the top of the radiator whilst I sorted out the hoses and checked for leaks and that kind of thing with initial running. The trouble is, because it's sort of quite cramped in the garage here, and the bonnet requires you to have one side up or the other, trying to work around it when you're sort of first firing it up and, you know, sorting it out and filling with the carb and that kind of thing, and putting out fires and whatever else happens. It's a pain in the bum having to sort of put one bonnet down, scuttle round here at the other side and open the other side and do that. So I took a piece of black steel rod and cut it to the length of the rod that was on the bonnet, that goes through the bonnet there, holds the bonnet, but also acts as a stay for the radiator, between the radiator and the bulkhead. And then welded studs on it the same distance apart as they are on the bonnet. So I know that roughly the radiator is in the right place when the bonnet is fitted back onto it. But this is rock steady, not going to go anywhere. And then it allowed me to check the alignment for the hoses. Oh, that's better. So it didn't look too bad. It was just that this outlet, it's a sort of dropped a little bit where it's settled down a bit, but it was a lot lower. So this hose would have been sort of bending upwards like that. It would have been forcing it up, and I didn't want to put too much strain on the brass radiator. I wanted to sort of minimise that as much as possible without upsetting the alignment of the bonnet. So even with the new rubber mounts on the bottom, it was sitting a little bit low. Just checking, this is in line this way, but it's a bit lower that way. I think what will happen is when the engine mounts soften up and the gearbox mount softens up and everything settles down, this will probably come back into line. You know, it might even get to the point that I'll have to take out the spacers I've put on the bottom of the radiator just to bring it up a bit. So this lines up a lot better, and this is almost in line here as well. So not too much strain being put on it all. I've managed to fill the gap. I think I explained before, this manifold, this hot air tubes, they've been weld repaired before, and I think it had caused some distortion, which left a big gap where the gasket goes, and I didn't want to strain, I didn't want to sort of tighten this bolt up, you know, to try and pull this in. So what I've decided to do, although I've had this repaired, is I made up a steel plate, marked it out, cut it out to shape, and then run it on the belt sounder to finish it off. And that takes up that space just right. I also turned up a stainless steel bolt, because the bolt that was in here was sort of worn, so I thought it'd be better to make a new one. So fired up the lathe and turned up a new sort of flange bolt to go on there. And the only trouble was, when I come to put it in, I'd put this top floorboard in. The only way you can get it in is with the floorboards out, so the floorboards had to come out yet again to drop that bolt in. So yeah, with that done, that's tightened up. And then I had to remember where I put my exhaust, which was up in the roof of the garage. So we had a rummage round up in the roof and carefully lowered it down without dropping it through the roof of the Riley. And then fidgeted it underneath, and it went back into position quite nicely. The bolts that were on here originally were only just long enough. So as I said before, got some spare gearbox bolts that happen to be the right diameter and they're a little bit longer, and the thread wasn't long enough, so just stuck them in the vise and ran a die down them to extend the thread on them, and then cut them to size and turned the ends down and finished the ends so the nuts go on them quite nicely, and bolted the exhaust on. So bolted it here and fitted the exhaust mounts further back, and it's all on there quite nicely. I just had to fiddle around with the earth strap for the starter down here, cleaned off the chassis rail so it sort of bolts to earth quite nicely, and just had to make sure it was out of the way of the exhaust. But it's not until you get these things back in, you sort of need to see where your cabling goes. Yeah, and the other things like these brass P clips that I've made to secure the battery cable have been screwed to the floorboard and secured that. So with the hoses on, it was time to put some water in it. So we filled it with water once. And of course you get the standard odd leaks round the hose clips where they weren't done up, hadn't done them up tight enough. So I think there's one here and there was one down here, so tighten them up. The repair seems good on the bottom of the radiator, so that's good news. But it was leaking from around here, the joint between the block and this bottom outlet, aluminium outlet, and there's a fibre washer in there, and it just wasn't sealing. You sort of tightened it up, not go too mad, because you've got a bronze saddle clamp type of arrangement that pulls it in, and you can distort that. So had to drop the water. So with the water out, disconnected this bottom outlet, and the block was painted around the outlet, but it was a bit rough with corrosion. I'd cleaned the rust off and then painted it, but it was quite rough, and I just think there was too many gaps for the water to dribble out of. The block's all in, so it's difficult to get to sort of try and machine it or anything. So what I've done is just got the Dremel and grinding and sanding discs on it, and sort of ran it round and tried to get the face a lot smoother than it was. And what I've done was I just had a sort of 321 block with blue ink on it, and I just sort of rubbed that over the mounting face and just check where my sort of high and low spots were, and just sort of keep going with the grinder until I got a nice blue ring of engineer's blue all the way around on the mating face, so I knew it was reasonably flat, and then bolted it back up, and then put water back in it, which seemed to hold. I had to sort of tighten this up a bit, but then it eventually stopped, so that was okay. But after a day or two, I was getting a little dribble of water coming from the front of the head gasket down here and on the other side. I think you can still see the dirt. I haven't rubbed it off yet. Yeah, just down here, sort of, dirty water down here, just from between the block and the head. There, it looked like it was seeping through the gasket material here. So I decided to retorque the head down, because if you go back on my videos, this engine's been assembled for about a year and torqued down the once, and it's just been sat here, and I suspect what's happened is the gasket's compressed a little bit when I first done it, and then it's sort of rested, gone down a little bit more over time, and slackened off a little bit. So what I done was took the rocker assemblies off like you do, because that's the only awkward thing with this design, is you can't get to the head bolts with these rocker assemblies on, so you have to take them off each side. And then I found that the gasket sealant stuff I'd used said it was easily, what did it say it was? So the well seal stuff that I'd used that says it's easily partable, it was a lie. It was a bugger to get apart, and it sort of shredded the gasket as well. So fortunately, when I ordered these gaskets, I ordered a couple of pairs, so I've got some spare ones, so that wasn't a problem. So to clean off all the gaskets, clean the faces back up, and then when I torqued the head studs, I set the torque wrench to 30 pounds first. I'd done them up to 40 pounds, or about 42 pounds before. And yeah, it sort of, so it didn't click straight away. So I knew that the torque had relaxed a bit. So set it at 30 first, torqued it down, and then 35, torqued them down again, and then went to 40 or just above about 42. I went to 40 first, and then I went, because that went okay, I went to 42 and left it there. And I haven't tried water back in it yet, but it has actually made a difference. The gasket material is actually squidging out between the two copper layers, which it wasn't doing before. It just looked like, you know, it looked like the gasket that I'd got out of the box, really. So yeah, there's been a bit of compression going on there, so I'm hoping that has sealed down, but we'll know in the next video. And the original problem with the car for pulling it apart in the first place was this bottom outlet on the radiator leaking at a pinhole on the bottom side of it. So I cleaned all the paint and crud off, and then carefully sweated the solder out, put lots of flux on it to keep it clean, and then wiped it over, soldered it and wiped it over a few times to get any muck out, just where I needed to, you know, just where I needed it to go, around where the suspected hole was, and then flowed some solder in to finish it off, and it seems to be holding okay. So cleaned that up, got the flux off, gave it a coat of paint. All bang tidy, as they say in Wales. I wanted the drain tap to work, and actually it's coming really handy where I've had to drain the system a couple of times. It was a bit seized up, put a bit of heat on it, it come apart. Just sort of put a light bit of brasso on it and run the taper through backwards and forwards a few times. Didn't go too nuts. And then done it all up, and it seemed to be okay. This isn't the original nut. I've made a new nut for this with a bit of a hollow in the mounting face of it to allow it to go over the square shoulder that comes through the valve, because with the previous one what was happening was that the nut was resting, it wasn't resting on this little plate here, it was really resting on the shaft, so it wasn't doing anything, it wasn't pinching this into its taper far enough. So turned this nut up, and then rather than the spring that it had on before to set the tension, I can tighten this nut down when the tap is closed, just so that it doesn't vibrate open at any time. Because unfortunately, to open it, it wants to go down that way. But you can see it's quite tight, and if it gets a bit slack, I can nip that up a bit. So yeah, put that on, that seems to hold water, so that's good. Another job. So we're getting all the linkages sorted out for the advanced retard and the hand throttle on the steering wheel, and also the foot throttle as well. So I've got that sorted. I said on a previous video this arm here was bent and the angle seemed all wrong. I'm sure it should have been flat, but it was bent this way, and it had a twist in it as well, which sort of put a bit of a strain on the throttle linkage from the pedal. Wasn't too happy about trying to heat it and bend it, or bend it in the vise, because, you know, that's the way of shearing it off. But now I've got the press, I popped it in there, managed to press out all the bends. So I just gently work my way along, pressing all the bends out of it. You know, it's bent in a few different places, and it had a bit of a twist on it as well. So I also held the eyed end in the press by putting two sockets on it to clear the ball end, but allow me to clamp the end of it, and then just with an adjustable spanner on the other end, carefully tweaked the twist out of it as well. So yeah, really pleased, all straight, not broken, and it's taken the strain out that was going on in here. This had a bow in it, and it was just coming from the wrong angle, so that was a job worth doing. Other jobs, just silly fiddly little things. This is what takes time. Turning up brass nuts and bolts there, and another one over there to bolt the P-clips that hold the wiring loom in position. And making them in brass means they're not going to rust up like the old ones. I'll be able to get them out if I need to. Yeah, I know the floorboards are back out again, but I just wanted to go through it and make sure all the split pins and washers were all in position, and all the bolts and nuts were done up tight, that I'd sort of had my spanner on over the time. This is one of the stainless steel washers that I turned up because I couldn't find the other ones, and yeah, they're easy to do. Just stick them in the lathe, turn up a bit of stainless steel to size, drill out the middle, part it off the thickness you want. One stainless steel washer. Because you just can't get nice washers this thickness anymore. They're all sort of thin, horrible things. So yeah, that done. Another job was turn up. This is the brake light switch that had grub screws in, and they were all chewed on the ends and had seen better days. So I turned up two brass screws, so you know you can get them down nice and tight, and they're easy to get to. I don't know why they use grub screws. It makes it a little bit more compact. I mean, sometimes these were used on, I don't know if these are used on motorcycles, maybe, but they're a little bit big and bulky. But it's a car, so the screws are fine. You know, doesn't make any difference. So with that done, it was back onto trying to get the floor in. So as I said in a previous video, I needed to carry out adjustments on the plates around the clutch and the brake pedal. So I took them off and got busy with the files, gaining a bit more clearance for them, so I could mount them back on the floorboards and sort out my clutch adjustment. So with the plates now giving me the clearance that I needed, it was just a case of finding the screws, which I managed to do, and screw them back onto the top floorboard, and then that allowed the pedals to sit in their home position, so I could get on and set the clutch up to its final adjustment. So to adjust the clutch according to the handbook, we need between 1/4 and 1/2 inch of movement on the clutch pedal before it engages with the clutch, and you do that by loosening this bolt AC in the book here, and there it is there on the clutch shaft. So you undo that, and that allows you to move that little actuator off of its splines and move it round 1 or 2 splines to get the travel you need. There's a bit of wear on the pins, so the clutch movement was a little bit more than ½ an inch, but it was not enough movement to get it in by moving it round to the next spline. So we'll leave it there. That's sort of roughly where it was when I took the car apart, and it worked fine. Yeah, you can see the little bit of play in that pin there. I could probably take it out by adjusting the rod that's going down, but to do that you've got to slide out the bottom shaft, and yeah, just didn't fancy doing that. So I thought it was a case of, if it ain't broke, don't fix it. So yeah, so just over sort of ½ an inch travel, so that should be fine. So with that done, it was just a case of working my way around the gearbox and inserting split pins where they were missing, doing up nuts and bolts where they were still loose from disassembly. Plates are in, clutch pedal is adjusted. Had a bit of a fight with the floorboards. They're cut at an angle, so they sort of slide into each other and sort of seal up against the elements a little bit. But one tucks in under the other, so this one holds the front edge of this one down. So you have to jiggle them about to get them back in, and being a wooden body as well, I think things move over time. So I had to really sort of struggle and fiddle around getting these back in. And then I could get my plates on around the pedals and get the, as I said, get the clutch adjustment done, make sure the brake pedal was okay, and the throttle pedal as well. So that's all done. The clock is out for repair. Like I said, it does work, but you can't get it started. I think the is it the escarpment mechanism or whatever they call it, seems to stick, so you have to sort of quickly twist the clock one way or the other and sort of flick it, and that'll get it started. Once it's started, it will run for 8 days, but when it's in the dashboard, you can't keep taking it out and, you know, twisting it to get it to work. So sort of carefully took it apart to have a look inside. Not sure if I'm going to tackle it yet. I've bought sort of pegwood and the cleaning stuff. I can't remember what they call it, that watchmakers use to clean dirt off of the gear wheels and that kind of thing. It's really small and it's jewelled, so I'm not sure whether I can do it. It might pay, you know, might pay me if I can find a watch clock repairer that still does that sort of thing. Maybe just get him to service the escarpment plate, because the rest of the clock, you know, the rest of the clock runs fine. So that's why there's an empty hole there. But we've been turning the regularly turning the car over. Every time I come in, it's got the crank handle in the front of it, and I always give it a couple of turns on the crank handle. And the other day I sort of wound it over a few times and then disconnected the oil feeds up to the rocker covers, took the plugs out and spun the motor over a few times just to see if one oil pressure would build up again. Which it does, and then the oil does come, you know, even on the crank after a few turns, eventually oil will sort of come out the top here. So I know I'm going to get oil up to the top, you know, in preparation for starting it. So another job done. So the next thing to do was to check the plug gaps, and for a magneto engine it's 18 thou or 0.45 of a millimetre for the spark plugs. So just check those with the feeler gauges, make sure they're okay. And then with those done, I put them back on the car, connected them to the HT leads, and earthed out the spark plugs, and then wound it over on the crank start to see if the magneto was still behaving after all this time. Yep. So with the plugs gapped up correctly, and we've proved that the magneto's firing okay, it's just a case of copper slipping up the spark plugs and popping them back into the cylinder head, and then reconnecting the HT leads, and we're one step closer to the big day. So there you go, progress is being made on the Riley. We're nearly there. Just got to sort of button up a few things, tighten down the rocker assemblies again, do the valve clearances, and then make sure Gladstone's going to sort of hold his water this time. And I think we're about there. We've got sort of, you know, carbs on, got sparks, exhaust is on. Yeah, nearly there. So hopefully next video we'll attempt to start it. But until then, see you later. All right, cheerio. Right, Gladstone, okay. Water in here, not down there. Got it? Oh, hello and welcome to Tweed's Garage, where on this video we're going to be doing some pardon me, dinner. away, away, away. So there you go.